Okay, so this is, I want you to imagine that this is our prime mover, okay? This is our prime mover, and this is our Regen-X quantum motor, okay? Or our Regen-X generator. This prime mover on this prototype is this, okay, the induction motor, and the Regen-X quantum motor is over here. Now, if we brought this motor up to 3,000 RPM or 3,400 RPM, which you're going to see here, on a scale of 1 to any number, what do you think the likelihood of this motor being able to increase the speed of the system without electrical input power? It's like, forget it, right? It's like impossible. And similarly, as a generator, this also operates as a generator. And again, what's the likelihood of this generator being able to accelerate the prime mover? Both suggestions are basically completely impossible by the existing scientific standards. Correct? Do you agree? So what we're going to do in this prototype, the Regen-X quantum motor, what I'm going to do is I'm going to bring the system up to rotational equilibrium, and that's where the net torque in the drive shaft is 0, the mechanical power in the drive shaft is 0, and you can actually come this way, closer. So this is the input side to the prime mover, okay? And this is the output side from the generator coils. When the switches are on this side, we're in quantum motor mode. And quantum motor is essentially just this, a Regen-X generator coil that has a low current delay that's built into it. And it's producing maximum acceleration, okay? And as well in this prototype, I have all of the coils are Regen-X coils, but number 3 and number 1 are also operate as conventional coils. So they're going to produce regenerative braking, and I want you to see what happens with the normal coil to get a frame of reference, and then what happens with the Regen-X coil.
Where's the input for the regenerative braking coming
from? The input, well, so we have the prime mover that's driving the rotating magnetic field, okay? And then we have the coils that are excited by the rotating magnetic field. So this is the torque speed curve for our prime mover, and we're operating in this region right here. It's a linear region. So what that means is once we establish rotational equilibrium, and we'll require about 450 watts to get the system to idle, to basically be idling. And
450 watts. Where's the 450 watts of power going?
the 450 watts of power is going to the prime mover to bring the rotor up to speed. And then what I'm going to do is then I'm going to put the quantum motor on and the RegenX generator, and I'm going to recharge the battery. I'm going to produce regenerative acceleration, and I'm going to produce regenerative braking, and you're going to see that. So if the consumption to the prime mover goes up when it's on load, that means the coil is producing a counter torque. That means it's operating as a conventional coil. And if the input to the prime mover goes down, that means the system is accelerating. And it's going to be pretty self-evident once we get into it. requires a certain frequency of operation in order to go into regenerative acceleration mode. And then below the critical minimum frequency, the regenerative coil will operate like a normal generator coil. And so when we get to the EV, above 30 kilometers an hour or thereabouts, we're in regenerative acceleration mode. And then when we drop below 30 kilometers an hour, we're in regenerative braking mode. And so that's the Regen-X quantum motor and the Regen-X generator coil. And now what I'm going to do is show you the next prototype, and you're going to be able to observe the load current delay. So you can stop it there, and then we'll do